Okay guys, hello and welcome. This is part 1 of 4 parts of renal tubular acidosis videos. It's going to be very quickly. I know you guys are taking the USMLE right now, you're preparing for it, so you don't have time for too much stuff. So I'm going to make it very, very high yield. I'm not just going to give you the symptoms and stuff. I'm going to explain what renal tubular acidosis is in a very, very good way. So without further ado, let's get right into it. Renal tubular acidosis, what's that? Basically, from its name, it's metabolic acidosis because of renal tubular defect. Let me get the pen quickly. Metabolic acidosis because of renal tubular defect. What is metabolic acidosis? Metabolic acidosis means low pH and low bicarb. I'm going to assume that you guys are familiar with acid base for now because you're all probably medical students, older medical students who have gone through this. So basically, metabolic acidosis, it's very easy to diagnose it. Low pH, low bicarb, low PCO2, that's metabolic acidosis, right? Okay, so it's metabolic acidosis because there is a renal tubular defect. You have to know first, what is the role of renal tubules in acid-base balance? And we're going to review that quickly. So first of all, the kidney does two jobs, right? First of all, it reabsorbs bicarbonate, right? Bicarbonate is a buffer that is used to buffer the acids in the blood. So if you have acidosis, you have low bicarbonate because that bicarbonate was used to buffer the acids and maintain your pH, right? So the first job of kidney tubules is to reabsorb that bicarbonate. The second job is to excrete the acid. I'm not going to do a lot of work here. I'm just going to remind you that bicarbonate is reabsorbed. Here it is. Here is the bicarbonate. Is reabsorbed by the proximal convoluted tubule. Okay? If you have a problem here in the proximal convoluted tubule, you have a very mild form of acidosis. Why? Because the main role of the kidney is to secrete the acid, is the acid excretion. The bicarbonate importance in acid base is basically just a buffer to maintain the pH. I'm not saying it's a very small role. I'm just saying clinically what happens when you lose that PCT effect, it's a milder form of acidosis because you can still excrete the acid with the distal convoluted tubule and the collecting duct, which I'm going to talk about next. So PCT, reabsorbed bicarbonate, that's all you need to know. Okay? And it's very important to know that this is done by the action of enzyme carbonic anhydrase. I'm not going to talk about the mechanism of bicarbonate reabsorption. That's for a whole another video. You can see my website. I talk about that in detail, but not for the people who don't have time. You're just here to understand the symptoms and signs and lab investigations of renal tubular acidosis. So I'm going to be very fast here. The second job is to excrete acid, like we said. So how does that happen in the kidney? And I have to know, this is a huge role. Okay, that's a huge role. If you have a problem excreting acid, you're going to get severe acidosis. The pH is going to be very low and the bicarbonate is less than 10. So that's what you need to know here. Okay, we're not going to talk about the RTAs yet. We're just going to talk about the physiology of the kidney's acid-base balance. How does the kidney help the acid base? Okay, so this is a huge role. So that happens in the distal convoluted tubule and in the collecting duct. Okay, what you need to know is that there is a pump that's called hydrogen ATPase. Okay, this pump excretes acid. All right, if you have a problem with that, you cannot excrete acid. You'll have huge acidosis. Okay, that's a big problem, right? I'm not going to talk about the details of acid excretion here, but that's what you need to know for DCT and collecting duct. If you have a problem here, that's a big issue. You cannot excrete acid. Okay, let's move on. Let's talk about the first type, okay, of RTA. So I'm going to make it very simple here. If you have gone through some videos about RTA, you probably know that it's 3 types we're going to talk about. In this video, I'm just gonna cover type 2. But what you need to know is that the problem in type 2 is the proximal convoluted tubule. Okay, that's type 2. I memorize it 214. Okay, 214. The problem in type 1 is the distal convoluted tubule and the collecting duct. And type 4, the problem is aldosterone. Okay, aldosterone. Aldosterone helps in the formation of these hydrogen ATPase pumps. Okay, all right, that's an overview of the 3 RTAs. Now let's focus on type 2 RTA. All right, I'm gonna move very slowly here, so in steps. Okay, So the pathophysiology, I'm going to talk about what is the first step that happens in the disease, what triggers that pathophysiology, and then I'll move forward and explain stuff along the way. Someone who has Fanconi syndrome. What is Fanconi syndrome? Fanconi syndrome is basically the complete destruction of the proximal tubular cells. It either happens by drugs like ifosfamide and tenofovir, so these are high yield. If you have a patient who has the symptoms of RTA, which I'm going to explain next, and you know that this guy has HIV and he's taking tenofovir, or he has some kind of cancer that's taking ifosfamide for, that's a sign for Fanconi syndrome, that probably this guy has Fanconi syndrome, which has other symptoms other than RTA, right? Like losing glucose, losing phosphate, etc., right? But here, I'm going to talk about the proximal convoluted tubule is just dead right now, okay? So they cannot reabsorb bicarbonate. That's what we just discussed, okay? So this is how Fanconi syndrome can cause type 2 RTA, all right? Think very slowly here. Don't really focus on the symptoms and signs of RTA. Let's just focus on the details, right? What happens like in the patient? Let's say a patient was completely healthy, right? And he has Fanconi syndrome. He got Fanconi syndrome. What happens so that his body goes through the pathophysiology and results in these symptoms? This is how I'm gonna move throughout, and this is how I move in the course. Like I explain very slowly what happens so that you can, go with me. So Fanconi syndrome could be as a result of drugs. It can also be just genetic. People have a genetic tendency to get these cells dead. I'm not going to explain that. We have a completely different video on Fanconi syndrome on the website. You can check it out. Okay. Multiple myeloma. How does multiple myeloma result in type 2 RTA? It results in death of the proximal tubular cells. And you have other symptoms of multiple myeloma as a result of the kidney failure too. So the light chains are actually filtered in the glomerulus, and they cause damage to the proximal convoluted tubule cells, leading to type 2 RTA. Just remember, type 2 RTA is just the proximal tubule function to reabsorb bicarbonate is screwed up. Okay, so this is multiple myeloma. Heavy metal toxicity like mercury or cadmium. If a patient was exposed to mercury or cadmium and he presents with symptoms of type 2 RTA, or abnormal bicarbonate or metabolic acidosis not in gap, you should think quickly type 2 RTA. Acetazolamide. Acetazolamide is an inhibitor of that nice carbonic anhydrase enzyme that we talked about in the previous slide. So this one. So it inhibits it. Basically, it's a cause of RTA because we inhibit the reabsorption of bicarbonate, so the syndrome, goes away. So that's the first step. Reabsorption of bicarbonate is screwed up. Okay, so now we're done with Fanconi, multiple myeloma, heavy metal toxicity, acetazolamide. Topiramate is an anti-seizure medication. It's a sodium channel blocker, and it results in type 2 RTA because it has the carbonic anhydrase inhibiting effect. So just like acetazolamide. Okay, so these are 4 high-yield causes of mild RTA or type 2 RTA. What you should know about type 2 RTA is it's mild RTA. So the patient may be even asymptomatic, right? Patients like Fanconi syndrome, multiple myeloma, these patients completely have destruction of the PCT, proximal convoluted tubules. They're going to present with symptoms. But I'm talking about just the reabsorptive capacity of the proximal convoluted tubule function. If that is destroyed, you're going to present with mild sort of acidosis. So you're going to be usually asymptomatic. Okay, so a patient who's in acetazolamide, for example, he might present with asymptomatically, and same thing with topiramate. Okay, so what happens next? So what happens in the type 2 RTA is that the PCT reabsorbing HCO3 function is destroyed. So you don't have the function of reabsorption HCO3 there anymore. So what happens? The bicarbonate is lost in the urine, right? So it becomes low. So if we go back, if you guys remember here, sodium is tightly controlled with bicarbonate. In order to reabsorb bicarbonate, you have to reabsorb sodium too. So if you have the function reabsorbing bicarbonate is screwed up, you're going to lose sodium too. And when you lose sodium, that is basically a diuretic effect, as if you're taking a diuretic, right? So as a result, physiologically, when you have sodium going through the collecting tubule, you get excretion of potassium because that sodium-potassium pump in the collecting duct is working. So it's reabsorbing the sodium, a lot of sodium that's that moved to the collecting duct and excreting potassium as a result. So potassium becomes low. So this is how the this is how it's happening, basically. Okay? But what you need to know is the acid excretion in DCT and collecting duct is intact. That's very high yield. Why? That's why it is a mild RTA. It's mild. The patient basically presents a symptom like, routine blood work. Okay, we find some abnormal acidosis in like low bicarbonate, abnormal potassium on the lab investigations. So that's basically how we just discover, oh, this patient might have RTA, and then we keep asking them about, do you take topiramate, do you take acetazolamide, etc., etc. Okay, so this type of acid excretion is this type of RTA is mild because the other function of the kidney tubules is intact. So we said two functions of the kidney tubules: reabsorb bicarbonate, and the other one is excrete acid. So the acid excretion function is normal. Okay, so the urinary pH is not alkaline, and this is very important because we're going to talk about that in other types of RTA, where you have the other type of RTA, type 1, which you have abnormal urinary pH. Normally, the urinary pH is under 5.5. So you're going to find there is normal urinary pH, which is under 5.5, because the patient is acidotic, so he has to excrete acid. So when you excrete acid in urine, you basically get acidic pH, acidic urinary pH. So appropriately, you have acidic urinary pH, less than 5.5. Okay, and the metabolic acidosis is not that bad because we're excreting the acid. Yes, we are losing the buffer, but any acid that's in the blood, we are excreting it. So it's mild acidosis. Urinary anion gap is negative. We're going to talk about that in another video. Okay, but basically, quickly, very, very quickly, what you need to know is that when the body is excreting acid, it basically excretes ammonia with it. Because if you excrete acid without excreting ammonia, you're going to make the urinary pH very acidic that it can destroy the kidney tubules themselves, right? The acidity in the urine is toxic, so we need to avoid that, right? So the body excretes ammonia along with the hydrogen protons to bind to each other to make ammonium, okay? So it excretes ammonia to make ammonium. So basically, urinary anion gap is sodium plus potassium minus chloride. Okay, where's the ammonium? Oh, I forgot to tell you that ammonium is excreted along with chloride. So in cases of acidosis, like this patient right here, the kidney is going to excrete sodium, the kidney is going to excrete a lot of ammonium, and the ammonium, because it's positive charge, is going to bind to chloride, okay? So the kidney also has to excrete a lot of chloride, right, in order to bind to the sodium, to the ammonium, right? So the chloride will be very, very high, okay? So the urinary anion gap eventually becomes negative, right? Because the chloride is high. We're subtracting chloride from the sodium and potassium. So the urinary anion gap is negative. Ammonium challenge test is going to be, it's going to lead to what? First, you need to understand ammonium challenge test. Basically, when you give the patient ammonium, what does ammonium does in the blood? It releases that hydrogen ion, right? So ammonium is NH4 positive. When you release the hydrogen ion, it becomes ammonia, right? So 3 and hydrogen ion. So basically, you're giving the patient acid. You're giving him acid. Eat acid, okay? And when he eats acid, he gets acidotic. So what does the body does, or what does the kidney does? It excretes that acid, right? So it excretes a lot of ammonium chloride, okay? So the urine pH should be acidic because we're excreting a lot of acid. So if the ammonium challenge test results in an acidic urinary pH, that means when we give the patient acidity in the blood, he excretes the acid. So that's what differentiates this type of RTA to the other types. Okay. All right, let's talk about the symptoms and signs, or symptoms and labs of RTA. First of all, like we said, type 2 RTA, it's mild. Why mild? Why mild? Because, like we said, it's discovered in routine blood work because the patient has acid excretion intact, which is the second function of the kidney tubules. The patient has generalized weakness, okay, because the potassium is low. The patient is acidotic. Don't forget that. The patient has metabolic acidosis, so he continuously tries to excrete that carbon dioxide. That's why we get low carbon dioxide, because he's dyspneic. He's hyperventilating to compensate for the low pH, okay, because CO2 is acidic. So you have to compensate, right? So that's the symptoms if he presented with symptoms, okay? Any patient with RTA basically presents with generalized weakness, dyspnea. What about the labs? Low potassium. Why? Why low potassium? We just said that. We just said that when you cannot excrete, when you cannot reabsorb bicarbonate, you also cannot reabsorb sodium. And when you cannot reabsorb sodium, sodium excretion increases. And when sodium excretion increases, potassium excretion also increases because of the physiological excretion by the sodium-potassium pump in the collecting tubule. So you get low potassium. Non-anion gap metabolic acidosis. We just discussed that, of course. The patient has low bicarbonate, is losing bicarbonate in urine. Of course, the organic acids in the blood that are normally created by the body are going to accumulate. So the patient will present with acidosis. Urinary pH is acidic. Why? Because he's excreting acid. Yeah, he is losing a lot of the bicarbonate, right? And he has more acid, but he also excretes the acid. So the urinary pH will be normal, will be acidic, as it's supposed to be in acidotic patients. Okay? Because the DCT and collecting duct acid excretion is normal. That's it, guys. I hope you enjoyed the video. That's just type 2 RTA. We're going to talk about type 4 and type 1 in another video. Okay? Just don't forget that 2 RTA is proximal convoluted tubule reabsorptive capacity of sodium bicarbonate is deficient. Type 1 is the acid, and type 1 and type 4, the acid excretion capacity is screwed up. Okay? And just remember the two functions of the kidney tubules in acid-base balance, which is reabsorbing bicarbonate and excreting acid. And also don't remember, like the renal tubular acidosis, what does it mean? Metabolic acidosis because of renal tubular function. And what's the renal tubular function? Reabsorb bicarbonate and excretes acid.